Well, we have a very unusual topic to deal with. It's one thing to have a topic about which people know nothing. It's quite another to pick a topic which everybody has all kinds of ideas about, but nobody really takes seriously. So we have a double whammy to deal with here. So we're going to talk about angels. And this first session is really going to focus on the whole realm that we find angels in. But I want to start right up front dealing with what we call the Berean challenge. It's been our trademark for many decades. And so we're going to talk about the misconceptions about angels, and we're going to talk about something else that gets in the way of really understanding them. Our misconceptions about reality. That's really what we're about, is to try to marry what we are told about angels with the reality that we experience that's around us. In a subsequent session, we'll really get into biblical angels and their characteristics and limitations, and we'll talk about the lineup of the major players that we encounter biblically. And there'll be a whole nother section of 2 sessions that will deal with the warfare that's behind the scenes. So in this session, I'm going to really focus on the Berean challenge in 2 ways. Not just about angels, but about our own reality. And our trademark, as you know, most of you are aware, has been our trademark for many, many years, from Acts 17:11. These were more noble than those in Thessalonica, in that they received the word with all readiness of mind and searched the scriptures daily to prove whether those things were so. Now, what's the most challenging part of that? For many, many years, I always used to feel that the challenge, that was a call to searching the scriptures daily. And indeed it is, but there's a preface, a prelude to that many of us overlook. And I want to get into that, the all readiness of mind. And see, I always felt search the scriptures as a challenge. I spent most of my many decades of materials here focusing on searching the scriptures, because it's the only reliable source of information, especially in the area that we're going to enter here in these sessions. But it's the readiness of mind that's the obstacle to most of us, the preconceptions that we bring to the topic. And it's amazing to discover that almost all the presumptions we make about angels are non-biblical. They come from cultural and almost comedic sources. But I also want to deal with a foundation that we all need, and that's to get rid of our misconceptions about reality, the discoveries of science. And some of the discoveries of 20th century science really assist us in understanding the Bible. Now, we all are victims of what I call modern mythology, mostly from our movies, to just use them as an example. Angels in the Outfield is a very colorful movie, very enjoyable entertainment, but obviously implants misconceptions about what angels really are. And there's also a very famous classic movie, It's a Wonderful Life, with Jimmy Stewart, and it has all these crazy ideas about when a bell rings, some angel gets their wings and so forth. No one takes that seriously, but that's just the point. It causes us not to take real angels seriously. And of course, as we will move subsequently into the darker regions here, we find even more misconceptions about the dark side of angels, if you will. So we need to realize that metaphors reign where mysteries reside. When we don't really understand something, we hide that with an idiom or a nomenclature to mask the fact that we really don't understand that. And so, are angels really real? Is a question we need to confront. And what difference does it make what your feeling is about angels? We'll discover it makes all the difference in the world. In fact, our spiritual hygiene is impacted by our understanding of the role and capabilities and limitations of angels. And what are the hazards from all of this? Are there vulnerabilities that we need to be conscious of? Are there issues we need to be sensitive to for our kids? There are exposures here that are actually very, very serious on a subject that most people don't take seriously. And of course, these popular misconceptions you see in Christmas cards and in Renaissance art, cherubs are little chubby babies with wings. We discovered cherubs, real cherubs, are very senior kinds of, and very, very serious kinds of angels. And they're also characterized typically as people, usually feminine. There's a feminization that goes on, which is antithetical to what the truth really is. And with every bell that rings, an angel gets his wings. None of us really believe that, but that misconception does something else. It pulls the rug of seriousness out from under what is an angel, and we're going to deal with that. What are their activities? You know, they don't play harps while floating around in clouds. These images that we use even in our comedies, even in our literature, is no one takes seriously, and yet that's the refuge of our conceptions. We need to outgrow those. And we see so much popular fiction about angels. And even though we don't take that fiction seriously, what we fail to probably appreciate is our failure to take it seriously also undermines our whole conception of about real angels. And it's very insidious. Their method of warfare. Some very, very insightful fiction has been written, but it portrays swords and shields and medieval weaponry as part of their toolkit, when in fact we know a great deal about their weaponry, and it's very different than that. And we need to deal with that. These popular topics, of course, emerge from, are very popular among the New Age movement. It's very popular among the occult groups. Probably every occult group is more entangled with angels than most people realize. And the Roman Catholic Church deals with this in some very non-biblical ways. And the other area that we should be on our guard, and it's probably of all these the most difficult ones, are the area of personal experiences. People who not only have experiences but publish books about their experiences, the after-death experiences. And these are very difficult because many of them would seem to be quite intense, quite sincerely proffered, and at the same time not necessarily biblical. And how do you validate these things? Someone comes to you with a very real experience they feel they've had, and they relate the experience. How do you validate that? What yardstick do you use? What criteria do you use for assessing that? Very critical. And on top of all this, the websites are multiplying that collect these adventures, these experiences, these after-death experiences. They're typically very closely coupled to that. And we see this, of course, there's a whole field of study of the paranormal. And among those things that there's discussion about, most people have discussed one way or the other, the whole area of UFOs. Are they real or are they not? They're real in some sense, and yet they're not real in another. Where do you stand on those things? And poltergeists, and there are books written on ghosts and all that sort of thing. And there are all kinds of messages from the dead and the afterlife experiences. These are on the websites from end to end. And the thing that we want to highlight is, what do we know that's really true, that's provable, that's verifiable, and what are the hazards and the dangers that lurk, especially in the dark side of these things. That's our challenge. And let's start by doing what we should always do, and that is measure these things by the Word of God. And of course, every time we enter the Word of God, I want to be reminded that we never go into that barefoot. We always go with our guide. So let's bow our hearts for a word of prayer. Father, we thank you for this opportunity. We thank you, Father, for those that are here and that are hearing my voice and seeing this presentation. We pray, Father, that your Spirit would prevail, that you would open our hearts and lives to your word. Give us discernment, and out of that discernment, give us resolve as we commit this hour and ourselves into your hands, in the name of Yeshua, our coming King indeed. Amen. So with that, let's turn to 2 Kings chapter 6. I love this passage because it's so vivid, so real, and so relevant to all of us. And it's going to give us a glimpse into what I'll call, for a lack of another term, the unseen realm. And we're going to try to understand this unseen realm, leaning heavily, surprisingly, on the recent discoveries of modern science. But let's just jump into this. We're in 2 Kings chapter 6, starting about verse 8. Then the king of Syria warred against Israel and took counsel with his servants, saying, in such and such a place shall be my camp. And the man of God, that's an idiom for Elisha, the man of God sent unto the king of Israel, saying, beware that thou pass not such a place, for thither the Syrians are come down. When it says the king of Israel, this is obviously talking about the division of the nation after the death of Solomon. The northern kingdom called itself the house of Israel, and I'll try to refer to it as the northern kingdom to avoid confusing that with the nation as a whole. Many people reading text out of context, when it says Israel, they're not talking about the whole nation, they're talking about the house of Israel, the northern kingdom. And Elisha followed Elijah as a principal prophet to the northern kingdom. And they're at war with Syria. And so the king of Syria, whenever he announced where he was going to be, somehow Elisha tipped off the king of Israel as to his whereabouts. And the king of Israel sent to the place which the man of God told him and warned him of, and saved himself there, not once or twice. In other words, this wasn't a single event. This was a pattern. And it didn't take long for the king of Syria to realize something was amiss here. So we get to verse 11. Therefore the heart of the king of Syria was sore troubled for this thing. And he called his servants and said unto them, will ye not show me which of us is for the king of Israel? He assumed he had a mole on the staff that was somehow tipping off his adversary. And so that's his assumption. And one of his servants said, none, my lord, O king, but Elisha the prophet that is in Israel telleth the king of Israel the words that thou speakest in thy bedchamber. This is, I believe, the earliest recorded instance of a phone tap. that somehow the king of Syria doesn't have a mole on the staff. Somehow there is a way that what is said in his staff meetings is reported to the king of Israel. So what does he say? He said, go and spy where he is, that I may send and fetch him. That is this prophet of Israel that somehow has an inside leak here. And that I may send and fetch him. And it was told him, saying, behold, he is in Dothan. Therefore sent he thither horses and chariots and a great host. And they came by night and compassed the city about. In other words, he didn't send a little team to check it out. He sent a whole army, in effect, the horses, chariots, great host, and circled the entire city. And so that's the situation here. So we get to the next morning, and when the servant of the man of God, that's an assistant to Elisha, when the servant of the man of God was risen early and gone forth, behold, a host compassed the city both with horses and chariots. And a servant said unto him, that is unto his boss, alas, my master, how shall we do? Get the picture. Overnight, the city is surrounded. The servant gets up in the morning, does his chores, and realizes they're surrounded by the Syrian army. And he's panicked. He turns to Elisha and says, my master, what shall we do? Now Elisha, I suspect, with maybe a little bit of impatience, said, fear not. He answered and said, fear not, for they that be with us are more than they that be with them. Now, I suspect that the servant probably figured this is not a time for a spiritual cliche. I can hear their engines running, so to speak, okay? And so Elisha prayed and said, Lord, I pray thee open his eyes that he may see. And I'm sorry, I can't resist the thought that Elisha maybe did this with a little bit of impatience. Let the kid see. Let him understand, Lord, what you and I know, in effect. So Elisha prayed and said, Lord, I pray thee, open his eyes that he may see. And the Lord opened the eyes of the young man, and he saw. What did he see? And behold, the mountain was full of horses and chariots of fire around Elisha. Fascinating passage. The servant didn't realize it, couldn't see the reality that between them and this hostile army was an army of chariots and fire that were invisible, protecting them. And, it doesn't take much imagination that if you were casting this in a movie, you could really take advantage of special effects to really dramatize that. And to see a reality that is normally hidden from view. Most of us think that reality is what we can see and touch and feel. And it turns out the reality that we can't see, touch, and feel may be more real than that which we can touch, see, and feel. And that's what we're going to get into here a little bit. Some of you that use computers a lot use a word processor. There are many different ones out there. And you can type a letter or a memo or what have you. But occasionally, not usually, but occasionally you want to change something around. You may want to make a word italicized, or you may want to change the font, or you may want to make a certain part of it bold. And so you can send some word processors, you can push a key which says the equivalent of reveal codes. And when you push that key, suddenly you realize that behind your text are other colors. There are commands that pick the type size and the color of it and the spacing of it and the tabs and the margins. There's all kinds of stuff going on that has to be resolved, but you don't want to be bothered normally, so you don't see that. But occasionally you want to be able to see that, so usually there's a code you can enable which allows you to see all the background. And you also that lets you make some changes. It normally would get in your way for normal routines. And it's often occurred to me that's our missing key in life. We need a reveal codes key, something we could push that would show us the chariots of fire, whatever, that God has positioned on our behalf that we don't even know about. And as we get more mature in our Christian walk, we'll be increasingly sensitized to the fact that we're watched by angels. And I'll talk to you about some practical examples that has occurred to me recently about that before we're all through here. So this opens our introduction, if you will. I want us to spend this initial session on this topic by laying a very relevant foundation to everything. I want us to explore the boundaries of what we think is our reality. And we're going to talk about the macrocosm, the limits to largeness. That the great discovery of 20th century science is that our universe is finite, not infinite. And we're also going to go the other way. We're going to talk about the microcosm, the limits to smallness. And that's such a big shock, some of the early physicists that realized that committed suicide. The implications of the limits to smallness is staggering in its implications for our understanding of our reality. And we're going to talk about something you may never have explored, and that's the metacosm. That's what's going on beyond the limits of our immediate perceptions of our reality. And so that's where we're going, the boundaries of our reality. Now, I'm going to make some diagrams here, and I want us to adopt a convention that moving to the right is larger. And we're going from small to large when we go from left to right in this diagram. And I'm going to position ourselves, the reach of man. I'm going to indulge in assuming the classic Vitruvian Man of Leonardo da Vinci, just to represent our anthropic reach. And we as people, how far can we reach? And the direction I'm going to start is the direction of largeness. So we're going to move looking at what's larger than ourselves, and I'm going to collectivize that under a topic I'm going to call the macrocosm, that which is larger than us. And that leads us into the fields of study called astronomy and astrophysics. And I don't want to get into a whole tutorial on all of that, but I want to lift a few insights that comes from studies in those areas. And so the first thing I want us to be sensitive to is the area of thermal decay. Now, heat, we all know that heat always flows from hot bodies to cold bodies. That's just an observation that leads to the first law of thermodynamics, in fact, several of the laws of thermodynamics. And if the universe was infinitely old, then the temperature throughout the universe would be uniform. The fact that it's not uniform is proof that it's not infinitely old. It's cooling down, in effect. So it's not infinitely old. So there's a whole bunch of ways to approach this. I'll use this simplest one to start with, that the universe had a beginning. And even scientists which argue about other subjects tend to agree about the singularity that started it all. It hasn't been around forever. It had a beginning. And that's what leads to these conjectures that we call the Big Bang theories, okay? And it's also destined for an ending thermographically. So we have the Big Bang. That's the explanation of science. First there was absolutely nothing, and then it exploded. Now, if you think that's logical and can stand on its own, you've got some other things to probably think about. But from the Big Bang, from the singularity, as they would call it, from that to the end, it ultimately has a heat death, because there will be a time, if nothing else changes, that the universe will be at a uniform temperature, no more work can be done, it ends in effect. And so we find ourselves thermographically within two limits already. And so, but along comes a guy by the name of Einstein that really opened up a whole new understanding of the world. In 1905, he formulated what's called his special theory of relativity, that length, mass, and velocity and time are all relative to the observers. But that led to a generalization of that, called his general theory of relativity in 1915, that there's no distinction between time and space. Another way of saying the same thing is he realized, as he was grappling with the properties of reality, that we live in more than three dimensions. We all know length, width, and height. We all experience what's called Euclidean geometry, a three-dimensional world. Einstein realized there's actually a fourth, and that fourth is what we call time. And it was his understanding of a four-dimensional universe that led to a whole revolution in thinking. And that is no longer just a theory. It's been confirmed 14 different ways to 19 different decimals. It's at this point, a real platform of understanding. It took about 60 years for it to be applied to physics, by the way, but that's where it had its big start. So we've just moved in our discussion beyond Euclid. Most of us have been in school, whether we realized it or not, we're taught what's called Euclidean geometry. That's a geometry that's limited to three dimensions, okay? But the most important lecture in mathematics was actually given in 1854 in June of 1854, George Riemann's metric tensors. And it took 60 years for that mathematics that he there announced to be applied physically. And it's interesting that Einstein himself went to his grave frustrated over his inability to reconcile other issues, which since have been subsequently have yielded by simply applying his insights. Einstein solved the theory of relativity by adding a dimension, and everything became clear. So he went to a four-dimensional space. And he died frustrated because there were other frontiers he could not resolve. If he had just done the same thing again, gone from not 4 but to 5 or 6, they would have yielded, and that subsequently happened. And in 1915, we have his four-dimensional space-time announcement. In 1953, Kaluza and Klein together went beyond four dimensions and reconciled light and supergravity to the equation. When you get to 1963, two guys, Yang and Mills, developed fields that reconciled electromagnetic and both nuclear force, the weak and strong nuclear forces. So by simply adding dimensions, these imponderable things suddenly yielded to understanding and clarity. And so on it goes. And from 1984 onward, most people that are in this field of study have come to the conclusion that there are at least 10 dimensions, not just the 3 or 4 that we're familiar with, the superstrings and so forth. The current thinking is that our universe consists of one-dimensional superstrings that are vibrating in 10 dimensions. We're going to talk more about that later, but I want you to understand that when you have more than 3 dimensions, we typically call those hyperspaces, just a fancy word for spaces of more than 3 dimensions. But I want to pause here, and also there's another, I don't want to get into the mathematics per se, but I want us to get a grasp of these quantities emotionally. And there is a very, very interesting handbook published by Robert Burnham, who ran the Lowell Observatory from 1950 through 79. And he's published a handbook in astronomy known as the Celestial Handbook. And he proposes a very provocative model. He noticed a coincidence that the number of inches in a statute mile happens to be about 63,360. And that happens by coincidence to be equal to the number of astronomical units in a light year. Now, an astronomical unit is a definition in astronomy. It's the distance from the Earth to the Sun. It's a basic unit of length within astronomy. And what's interesting is that basic unit of astronomy within a light year is roughly the same number as the number of inches in the statute mile. Very close. That gives rise to a useful coincidence. Let's build an imaginary model of our universe using that ratio. In other words, we're going to use that as a scaling ratio. We're going to 63,360. We're going to say that's essentially equivalent to 63,300. So we're close. And so we're going to let 1 inch represents the distance from the Earth to the Sun, a standard unit. Okay? And 1 mile will represent 1 light year. You with me so far? So just bear with me here a little bit. Let's build that model. Well, how big is the Sun? Well, if it's about 880,000 miles in diameter and it's about 93 million miles away, that turns out the Sun itself would be represented by a period. It's about 1/100 of an inch. In our model that we're building, we're going to have something 1/100 of an inch, and let's just imagine a period, or if you have a very sharp pencil, a very tiny speck represents our Sun. Good so far. All planets, it turns out, would then be able to be built in our imaginary model here within a 7-foot circle. Okay? In other words, Mercury would be 4/10 of an inch away from that speck. Venus would be 7/10 of an inch in that speck. Earth would be 1 inch. In other words, by definition, 1 inch is an astronomical unit. That's the definition of an astronomical unit. So we're using a 1-inch scale as we build this model. And Mars would be about 1.6 inches, and the Jupiter would be about 5.2 inches, Saturn about 9.5 inches, Uranus about 19.2 inches, and Neptune about 30 inches out there, and we get to Pluto, it's about 39.5 inches. So they call it nominally a meter in radius, okay? And so, when I say a 7-foot circle, I mean a diameter of 7-foot circle. So that's our solar system. If we built this model, we could easily contain it right here in the auditorium. Okay. Now, the nearest star to us is Alpha Centauri. Alpha Centauri, conveniently, is about the size of our Sun. Okay. Now, the nearest star is 4.5 light years away. In our model, you see, that equates to a speck, the size of our Sun, size of, say, a period on your paper, 4.5 miles away. We can't have it here in the auditorium. We'd have to, it goes, I want you to think 4.5 miles. And I want you to remember something else, if you remember the math. See, we've got 2 specks of dust that are separated by 4.5 miles. And I want you to remember that according to the Newton's universal law of gravity, you take the product of the masses and divide by the square of the distance between them. So not only is it 4.5 miles away, it mathematically has to be that squared, like 20 miles equivalent, so to speak, if you're with me. So the question that lurks in our minds, how much influence would gravity have between these 2 specks? 2 specks the size of a period, separated by the equivalent of 20 miles of distance, or 4.5 miles squared, if you will. See, what you discover as you explore these topics is that most astronomers have presumed a gravitational universe. Gravity is very useful for our solar system because the distances are nominal. The minute you start talking about stars and galaxies, gravity is a non-player. And I want you, it's amazing to discover here is a science populated by brilliant people that are victims of their own presumptions, interestingly enough. If we look at the fundamental forces, and we won't go into, I'm drawing, of course, on a series of studies. We have the Beyond Perception, the Beyond Time and Space, the Beyond series, we call it. I'm drawing on some of those just to get some conclusions here. As you look at the 4 fundamental forces, you discover very quickly that gravity is eclipsed by electromagnetic by a factor of 10 to the 36th. In other words, electromagnetic forces are 10 with 36 zeros after it, more intense than gravity. And it works plus and minus. Gravity doesn't, we haven't found an anti-gravity force, but electromagnetic goes in both directions. So it's vastly, compellingly the dominant factor, especially as you start increasing long distances. What we've discovered in recent years is the universe that you see in a telescope. If you're talking about stars and galaxies, you're looking at electrical behavior, not gravitational behavior. We actually have what people are beginning to call, finally, the plasma universe. The plasma physicists have been saying this for years, but no one's been paying attention until recently. And we have a briefing package on that called Beyond Newton, and I encourage you to look at it if you're interested in that. The effects of gravity are minuscule on the universe. The effects of electromagnetism can be 10 to 36 times as great. The entire volume of our galaxy is filled with diffuse clouds of magnetized plasma, electrically charged, ionized particles. And they behave very understandably, but very non-intuitively. And so 99% of all matter is not gas, liquid, or solid, it's plasma. Plasma is not just a gas, it's an ionized gas. It behaves as an organ on its own. And some experiments in Europe, GEO 600 experiments, now suggest they think they have discovered it actually is holographic in nature. And that's a whole other study that goes beyond our view right here. But we can't help, as we study our Bible, we keep encountering another phrase that I think we need to pay more attention to. All through the Holy Scriptures, Old and New Testament, it speaks of stretching the heavens in the English translations. I want to talk just briefly about the fabric of space. Most of us presume there's nothing more empty than empty space. In other words, you get away from clouds and whatever, you get out into real deep space, it's empty. And it turns out we're wrong. There is a fabric of space. This is more than just a metaphor. The scripture says, who alone stretches out the heavens in Job 9, stretching out the heaven like a tent curtain in Psalm 104, who stretches out the heavens like a curtain and spreads them out like a tent to dwell in. These could be just poetic phrases, idioms of the author, and that's fine, except maybe we should pay more attention. He has stretched out the heavens. In Zechariah 12, the Lord who stretches out the heavens. And in fact, we could go on and on and on, example after example. We discover that phrase permeates the whole Bible. It goes far beyond an idiom chosen by a penman. There's something more fundamental. And I have to tell you candidly, in the over 60 years that I've been made the Bible my hobby, I have come to the view to pay attention to the details. They're not actually, I'm convinced that every detail, every number, every letter is there by deliberate design. And I also believe there are no such things as synonyms. Two words can be synonymous in that they mean almost the same thing. But watch out for that word almost, because hidden in it is usually a discovery of some kind. So with that view, let's continue here. Space, we now discover from the scientists, is not an empty vacuum, as most of us assume. The Bible says it can be torn in Isaiah 64. It can be worn out like a garment. Psalm 100. You can wear out space? Apparently. It can be shaken. You can shake space. Hebrews 12, Haggai 2, Isaiah 13. Use those ideas. It will be burnt up, Peter warns us in the second letter. Revelation all goes on and says it can split apart like a scroll. Wow, what's going on here? It can be rolled up like a mantle, according to Hebrews 1, or a scroll in Isaiah 34. These are clues. These are clues to the physics of space, by the way. Let's take a look at this. What do you mean it's rolled up? If it can be rolled up, there must be some dimension in which it is thin in order to be rolled up. In order to be rolled up, it means there must be some dimension in which it can be bent. If you have a two-dimensional thing like a photograph, to roll it up requires a third dimension. If you have a two-dimensional sheet of paper and you want to fold it over, or you want to tear it in two, that implies a third dimension to your two-dimensional piece of paper. You with me? Okay. So there's a direction to which it can be bent toward. So all this this language implies that there are additional spatial dimensions, and if you talk to specialists in the study of these things, they will tell you that 10 is a current estimate of how many dimensions we're dealing with here. Now, a 10-dimensional universe, really? And I'll show you where that was first discovered, and it wasn't in the scientific laboratory. 10-dimensional universe. And when we get to read the Bible, we discover that most of what we know about the creation is after Genesis 3. We know very little about the creation prior to Genesis 3. Why? Because in Genesis 3, we have the fall of Adam, and as a result, God announces a curse. And there is a view, prevalent among some scholars, that when he announced that curse, it fractured the creation into two parts. They took the 10 dimensions and split it into 4 plus 6. Those 4 dimensions that you and I experience, the 3 spatial dimensions in time, we call the physical universe. This podium, whatever, we think that's part of a 4-dimensional environment. 3 spatial dimensions and time. These other 6 dimensions we glibly relegate to the spiritual universe. And that may be that's really synonymous, or effectively synonymous, with the 6 dimensions that are not directly accessible to us. But they are the target of study by our particle physicists. And I'll show you'd be amazed at what's being spent to understand that. And so the idea that this partitioning is an effect of the fall, the curse in Genesis 3, it introduces a concept in mathematics called entropy, or randomness. And in Romans chapter 8, verse 21, it speaks of the bondage of decay, that the creation is subject to the bondage of decay, and it associates that with the curse. So there's some of us that are interested in physics that suspect, we obviously don't know, but we suspect that the concept of entropy was introduced as part of the Genesis 3. And the universe was fractured then, in a sense, the separation of the 4 and 6 dimensions. That separates what we call the physical and the spiritual world. Those are metaphors reign where mysteries reside. Redemption in the Bible, by the way, involves more than man alone. We're overwhelmed as we realize the extremes God has gone to rename mankind. What we overlook is that all through the Bible it points out that there's more at stake than just us, because we know that there'll be a new heavens and a new earth in both Isaiah 65 and 66, and of course in Revelation 21. So there's more going on than just the repair or replacement of us as individuals. It's the universe itself. So a few other comments about the universe that is not essential for our thing, but just to give you a little more background. People who study the stars, the spectral thing, they talk about the red shift. Back in the 1920s, Edwin Hubble suggested that the red shift we observe in the star spectrum is a result of the Doppler effect. And that's why they call that Hubble's law. That's why the Hubble telescope was named after him. And that explanation for the red shift is widely taught even today in college astronomy courses, but it's wrong. It's out of date. Back in 1976 and following, William Tift of the Stewart Observatory in Arizona, he noticed and documented, spent 20 years of his life documenting what he calls aberrant red shifts. They don't shift to the red alone, they shift differently. And he discovered that they're digital, that they're always shifted by like a piano key. There aren't any things between the keys. It's always a unit that's definitive. In the 1980s, Guthrie and Napier at the Edinburgh Observatory spent 10 years challenging this view and ultimately confirmed that Tift was correct, that they're digital, which means there can't possibly be the Doppler effect. There's some other cause. There's a thing called the Rydberg formula, and that was invented by a Swedish physicist back in 1888. And it's what atomic physicists use to describe the wavelengths of the spectral light of chemical elements. And you see these in spectrums where you see certain lines. From those lines, they can tell what a star is made of and so forth. And the spectral lines on hydrogen here are shown on a logarithmic scale. Some people call it the barcodes of the atom, if you will. And it turns out these spectral lines we now know are due to the electrons moving between the energy levels within the atom. So if is there a shift in the lines, that's because there's a change in the very fabric of space itself. And that's now been confirmed in recent years. and the spectral shifts. Robert S. Mulliken back in 1925 noticed that the wavelengths shifted from the theoretical positions, but he was the first to recognize that energy in space was battering the atoms and affecting their movement. That was controversial, but recently been confirmed. And this energy that he's talking about is called the zero-point energy. And you're probably not one physicist in 100 that has ever heard this or knows anything about it, but the zero-point energy, Max Planck back in 1911, and then subsequently Einstein, Stern, and Nernst and others recognized that this pervasive energy was a universal phenomenon and it was intrinsic to space. And through the work of Heisenberg and others, it became understood that Planck's constant was actually the measurement of the uncertainty and position of subatomic particles. And by 1962, it was realized that this uncertainty of position was caused by battering from the zero-point energy. This energy, incidentally, is independent of temperature and mass, and that's a whole other insight. But moving on here, it was in 87 that Halputov showed that the electrons stayed in their orbits and did not go either spinning out or spinning in due to the expended energy, precisely because the energy they received from the zero-point energy. Ever wondered, you see these models of an atom with a nucleus and electrons spinning around it, you ever wonder why it doesn't slow down? Or why it doesn't speed up and spin out? Why is it held there? And there's a balance between it and the residual energy that's in space itself. Using 25 methods, 475 measurements on 11 different related quantities, confirmed the energy equation, H times C. H is Planck's constant. And what they're discovering is that Planck's constant is increasing and the speed of light is decreasing. The product has to be a constant because the energy stays constant. But the fabric of space is changing. Planck's constant is actually changing. And that's only been discerned and confirmed. It was a controversial proposition many years ago. It's now been confirmed in our experience. And the implications of that are staggering for you and I in our study in angels. And you'll see where I'm going here. The properties of space. We discover there's zero-point energy. It's actually 10 to the 95 ergs per cubic centimeter. It has permittivity. It has permeability. The product of those are called impedance. You probably never thought about, if you're a radio ham or an electrician, part of the reason you have an antenna, you matching the impedance of your device with the impedance of space. Space has impedance. We're not talking about the atmosphere. We're talking about space itself. And the velocity of light is also one of the properties of space. Now, so what we've done here, I've taken just a quick little excursion in what I'm calling the macrocosm. And obviously it's a topic we can't even begin to even summarize in this brief talk. But I wanted to get you to be aware of a few conclusions. We know that the macrocosm had a beginning. We know it is finite. It may be expanding, but it's finite. It's not infinite. That is the most profound thing for us to grasp here and understand. We also know that there's a fourth dimension called time. That's Einstein's theory of relativity, the big event of the 20th century. And the summary of all this, I want you to carry with you as we go forward, is the universe, in the macrocosmic sense, is finite. It may be expanding, but it's not infinite, is the point. And that's a staggering implication. So now what I want to do is go the other way. Let's look at in the other direction, and I'm going to we're going to go to smallness. I'm going to call that world the microcosm. We're going to exchange our telescopes for microscopes, so to speak. We're going to go look how small can we deal with things. And this leads us into the field called quantum physics and subatomic particles. Relax, we're not going to get into the vocabulary of all those things. We have a thing called beyond perception that gets into that if you want to get into that. But let's start, though, with a simple concept of the atom. Probably the smallest thing you and I can imagine is an atom. It's the base. Let's just take, a hydrogen atom. It's got a nucleus. It's got an electron buzzing around it. We think we can imagine that to some extent. That's one way to represent it. There's a nucleus, one proton, and an electron floating around it. It's in itself. It's electrically neutral, obviously. And now, this is not the scale, obviously, but let's see how far we are off. We know that an atom is about 10 to the minus 8 centimeters. That's very, very small. The nucleus is obviously a lot smaller, about 10 to the minus 13, to give you just a rough feeling for this. You don't have to remember the numbers, but you do want to remember the ratio of them. because the ratio is 100,000. In other words, whatever the atom is, the orbit of the electron is equivalent to 100,000 times away. If we made a model here and used a golf ball to simulate our nucleus, the electron would be 3 miles away. Visualize a golf ball, visualize something spinning around it with a radius of 3 miles. Now, I want you to get just a feeling for the sizes here. Okay? Let's carry that one. That's just the linear distance. In other words, the ratio of that orbit is 100,000 times as big. You with me so far? Let's talk about the area that it includes. You have to square that. The area ratio is 10 to the 10th. In other words, 10 to the 5th times 10 to the 5th. The volume that it occupies has to be cubed. It's 10 to the 5th times 10 to the 5th times the 10 to the... That's 10 to the 15th. That means that in our little golf ball model that we have to have a volume that's 10 to the 15th times as big as the volume of the golf ball. You with me so far? I'm going to suggest to you that 10 to the 15th is a ratio beyond our imagining. That's the same ratio as 1 second would have to 30 million years. Now, scientists who believe the universe, they generally have a perspective that says, well, the universe is about 15 billion years old, right? Oh, we're talking about 30 million years. Let me not confuse the situation. 1 second divided by 30 million years. So how solid is this podium? I'm standing up here. You're looking at this. Boy, there's this podium. How solid is it? Is this really solid? Or is it just empty space? Those are two extreme possibilities. Well, it turns out that conjecture number 2 is more descriptive than the number 1 by that same ratio. 1 second to 30 million years. So what you and I think is tangible and real ain't by any rational standard. You with me so far? See, part of our problem as we talk about some of these other things is the failure to really grasp how synthetic our concept of reality really is. See, that as we go into the field of the microcosm, we discover something even more shocking than anything I've said so far. We discover that everything is made up of indivisible units. What do I mean by that? If I take a line of any length, I obviously can cut that in half. No problem. If I take 1 meter, I can cut it in half and throw half it away. No problem. You think no matter what I've got, I can take what's left, divide it again, and throw the other half away. And even though I may want to go further than I can physically, in my mind's eye, my presumption is I could do that forever. Whatever I've got left, I can divide it in half and throw the other half away. And it turns out that that's true up until a limit. And that limit turns out to be 10 to the minus 33 centimeters. That's very, very small. But if I get that small and I try to divide that, it turns out what's left loses a property called locality. It not only can't be done, it becomes connected to every piece of the universe. There's a property called non-locality that is staggering in its implications. And they lose locality, and that's true of length, 10 to minus 33 centimeters. It's also true of time. There is a unit of time that you can't get smaller than. It happens to be very small, sure, but 10 to minus 43. It turns out that the prevailing constant that deals with this is called Planck's constant. And so as we try to get smaller, we run into a wall. I'm going to call we run into a Planck wall. There's a Planck constant for length, time, mass, energy, virtually every property. The world of quantum physics is a world that has discovered that everything we experience is made up of indivisible units. Units can't be smaller. They call them collectively. They call them quantum. That's why the quanta plural, quantum singular, that the study of quantum physics is a field of study in which you throw the rule books you've heard out the window. It is non-causal and non-deterministic. Everything is probabilistic in some very strange ways. Nothing is real. We cannot say anything about what things are doing when we are not looking at them. If you get our Beyond Perception briefing pack, we get into the two-particle experiment. When electrons are going singular or as a group, they behave differently depending upon whether you're watching them or not. That sounds crazy, but I'll leave you with that for now. See, reality turns out to be non-local. Every particle in the universe is somehow connected to every like particle in the universe. And this has been proven in the laboratory. Back in 1964, John Stuart Bell of CERN in Geneva formulated a mathematical approach to demonstrating non-locality. He called it the Bell inequality. He developed it theoretically and published it. We didn't have the technology to challenge it at the time. But when you get to 20 years later, in 1982, Alan Aspect, Jean Delbard, and Gerard Roger at the Institute of Theoretical and Applied Optics in Paris conducted a landmark experiment, the so-called two-particle experiment. Two photons from heating cesium atoms with lasers, each traveled in opposite directions through 6.5 meters of pipe to special polarization analyzers. The filter switched in 10 nanoseconds, 30 nanoseconds less than the 13 meters of travel between them. And the astonishing conclusion of the experiment is that photons did demonstrate their non-locality. They were connected in a way that implied faster than the speed of light intimacy. And that's been proven a lot of other ways. But that was a landmark experiment to people who are interested in this kind of thing. And so, now, Niels Bohr, one of the famous founders of quantum physics, anyone who is not shocked by quantum theory has not understood it. The more you understand it, the less you can deal with it. And Boltzmann actually committed suicide because he couldn't handle the implications of it. And there are a lot of quotes. To give you some feeling for what's going on in that part of the world, we want to touch briefly on the Large Hadron Collider. They're probing the limits of smallness with this collider. And what is this, the Large Hadron Collider? Colliding protons will recreate energies and conditions last seen a trillionth of a second after the final moment of creation. That's the concept. At CERN, which is an internationally known center, it's the European Center for Nuclear Research, and that acronym is actually it's an acronym from a French phrase that I won't mispronounce to embarrass myself here, but it's an acronym from the French. But everybody in English just calls it CERN. It's the European Center for Nuclear Research. They have spent over $8 billion, with a B, $billion, over 14 years. You have over 10,000 scientists from over 100 countries participating in this project. And it's a huge contraption. I'll show you just a few glimpses of it. The Large Hadron Collider is on the border between Switzerland and France near Geneva. It's over 300 feet underground, okay? It's the largest machine in the world. It has a circumference of 17 miles. It's the fastest racetrack in the world. Trillions of protons traveling at 99.99% of the speed of light, guided by over 9,300 magnets, 600 million collisions each second, traveling at an energy of 7 tera-electron volts in an ultra vacuum that's 10 to minus 13. That's 10 times the vacuumness of the moon, and at temperatures that approximate over 100,000 times the core temperature of the sun. This is the contraption they built to try to understand the limits to smallness, in effect. And there's a few pictures to give you a feeling for the scope of this contraption. And it's 17 miles in circumference, and the complexity of it is non-trivial, and I won't go through all that here. All this is to probe beyond Euclid, of course. As I told you about, we had the underlying mathematics was in 1854. Took 60 years for Einstein to apply it to the four-dimensional space, and then Kaluza-Klein and Yang-Mills have brought it up to date to where today people look for 10 dimensions. So to summarize what we think we want to remember as I go forward from this quick survey of the microcosm, everything we know is made up of indivisible units. length, mass, energy, time, Planck's limits. And we're not talking about 3 dimensions, we're talking about 10. With me so far? Now, what makes this kind of provocative to me, there was a guy by the name of Rabbi Moses ben Nachman, who it goes by the nickname Nachmanides, back in the 12th and 13th century. And he concluded that the universe has 10 dimensions. He said that only 4 of them are knowable, 6 of them are not knowable in his vocabulary. It's interesting that particle physicists in the 20th century and beyond have spent billions of dollars, building elaborate particle accelerators to learn what Nachmanides discovered by doing his homework in the Genesis text. Because we now know there are 10 dimensions. 4 are directly measurable, 3 spatial dimensions in time, and 6 are curled in less than 10 to the minus 33 centimeters, and thus are inferable only by indirect means. We know they're there, but we can't get at them. That's why we're spending all this money. And I think that's kind of interesting. The Bible anticipated that. And so, the boundaries of reality. So, and here's probably the most important diagram of the whole session. So follow me carefully. We put the reach of man in the middle. We explored the macrocosm, from which we discovered a 4th dimension called time, that it had a beginning, and that the universe is finite. You're with me so far? On the macrocosm side, we discovered that made up of indivisible units, there's 10 dimensions. The astonishing conclusion, as you grapple with what we've just put on the table here, we discover that you and I are bounded in a finite domain. There's a finiteness to the largeness, but there's also a finiteness to smallness, and that's even more staggering than the other. So you and I find ourselves in a virtual, digital environment made up of indivisible units, and it's simulated. There's a limit to how big we can conceive and experience, and how small we can experience and conceive. We'll call this larger, that goes beyond those limitations, the metacosm. Macrocosm is larger, microcosm is smaller, but outside both of those boundaries is an environment, for lack of another term, I'm calling the metacosm. And it's interesting that the Scientific American in June of 2005 had an article about the fact that the constants are changing, and their words, not mine, says if the constants are changing, which they are, our universe is but a shadow of a larger reality. Wow! When I first encountered that, good for them. That's what the Bible has been saying all along. And it's our grasp of that that's essential, in my view, to really understand. When we start talking about angels, you're talking about individuals, sentient, knowledgeable individuals that are in the metacosm. They're not constrained within the physical environment that you and I find ourselves. They may travel in and out of our environment, but they have a larger domain that is native to them. And so, let's see what the Bible says in Ephesians 3. It's an interesting verse. Ephesians chapter 3, starting verse 17, says, Paul is saying, that Christ may dwell in your hearts by faith, that ye, being rooted and grounded in love, may be able to comprehend with all saints what is the breadth, the length, and the depth, and the height, to know the love of Christ, which passes knowledge, that ye might be filled with all the fullness of God. Wow, it's quite a tour there that Paul is so skilled at. But did you notice something there? That you'll be able to comprehend the breadth, the length, the depth, and the height. Whoops, wait. How many are there? 4 dimensions, okay? And to maybe be able to get the breadth, the platos in the Greek, suggesting the length, which is mekos, which is length, the depth, bathos, which is depth of deep things of God, and height, which is hupsos, which is heavenly or broader and what have you. But again, we've got 4 dimensions here, and in fact, the 4th term, my friend Ron Madsen pointed out to me, doing a word study on this, is suggestive of the other 6, not just 4. You can argue that the other 6 are embraced in that, not just time, as I usually perceive it. But we have these 4 dimensions, and I suggest that that's provocative because that's your scripture. And should we be surprised? No. We're never surprised. It's amazing how the scripture anticipates. We've just moved into the discussion of hyperspaces. Space is more than 3 dimensions, more than Euclid. And so spaces are more, that's a fancy word for more than 3 dimensions. Now, there are only 2 kinds of people that can really deal with more than 3. We're so used to 3 that the only way you can deal with that is if you're a mathematician with special training, or if you're a small child. They have no problem with that at all. And we have, because we're programmed, okay? But because that's true, it turns out it can be quite illuminating. We can't go, I could talk 3, 4, 5 dimensions. It wouldn't mean much to you because we haven't had the training for that. We can go the other way, though. We're 3-dimensional beings that mess around with 2-dimensional things. Drawings, papers, photographs, so forth. So we can learn something about dimensionality by exploring that a little bit. So I want to introduce 2 people. But I want you to be compassionate because these 2 people I'm going to introduce you to have a serious handicap because they live in only 2 dimensions, Mr. and Mrs. Flat. And I'm drawing from a idiom from Edwin Abbott, a churchman of the turn of the century that wrote a little novel about flatland. But I'm drawing on his idioms here as a way of communicating some useful things about dimensionality. You see, I can have 2 two-dimensional universes, 2 pieces of paper on which are 2 individuals that live in 2 dimensions, Mr. Flat and Mrs. Flat. Now, Mrs. Flat has no concept of leaving her 2-dimensional space to get into his 2-dimensional space. She doesn't even know it exists. But I'm a 3-dimensional being. So I could come along and pick her up and move her into his environment. And to her, a miracle has happened. We've just gone through trans-dimensional travel. She went into a universe she didn't know existed, which is trivial to us because we are 3-dimensional. See, I want you to understand what an extra dimension can mean. There's something else that it can mean. If I have 2 people in a 2-dimensional universe and I come along as a 3-dimensional being, I can be more intimate with each of them than they can be with each other's. They can be several feet apart and I can be a millionth of an inch away from each of them, no matter where they are. Why? Because I have an additional dimension. We get a feeling for what an additional dimension can mean, okay? Now, let's assume I poke my finger through their universe. They don't see my hand. They can't conceive of that. What do they see when I put my finger through the universe? They see a circle. They can see the intersection of my existence with their 2-dimensional universe, which would be presumably approximate a circle, right? And putting it another way, if a ball, a 3-dimensional ball, is floating through space and passes through their 2-dimensional universe, what do they see? They see nothing, a dot that grows to a circle and then shrinks to a dot and disappears. They have no idea what happened because they can't conceive of a 3rd dimension, its implication. See what, I'm trying to get what an additional dimension can imply. And so, now, suppose I'm trying to communicate to them, they're in a 2-dimensional world. How do I communicate a 3-dimensional object to a 2-dimensional universe, a person in a 2-dimensional universe? That's a challenge, okay? One way I could do it is by giving them a projection. I can take a 3-dimensional object and project it into 2 dimensions and try to use that to communicate. It turns out to be pretty clumsy, not too helpful. See, here is a 4-dimensional cube projected into a 3-dimensional space. There are some of these on the internet you can play with, but as you play with them, you begin to realize they're obviously not intuitive. It's very tricky. Another way I might try to communicate a 3-dimensional object to a 2-dimensional universe is to unravel it. I can take my 3-dimensional box, for example, and I can just unfold it, lay it out flat. We've all done that if you folded up a box. I can do that, and I now have a 2-dimensional unraveling of a 3-dimensional object. Do you think that will give them any concept of it? Probably not. Okay? Now there is a device that is a four-dimensional cube that's unraveled in 3 dimensions, and that's what it looks like. It's called a tesseract. And it's known to people, mathematicians, of course, because that's what they study. But there's only one place that I'm aware of, personally, where a tesseract has actually been applied, actually been used in a useful way. And that may surprise you where that occurs. And that's Salvador Dali's famous painting of Corpus Christi. It stunned me to realize that Salvador Dali was that sophisticated mathematically to realize that the crucifixion of Christ involved more than 3 or 4 dimensions, and to adopt a tesseract as his concept of the cross shows a mathematical reach that startled me. And so I share that with you for whatever it might be. But let's go back to something else. We're talking about hyperdimensional travel. I want you to recall a record of hyperdimensional travel that's familiar to you. There are a group of disciples that were shattered and shook and frightened, that were hiding in a room. The room had a floor and a ceiling and 4 walls. And the doors were locked because they were terrified. They didn't know what was coming. Their leader apparently had been killed. Now they find out even his tomb is empty, and they're not quite sure what to do about all that. They're in this room of 6 sides, 4 walls, floor, and a ceiling. And who shows up in the middle of it? Our Lord, just symbolically represented here. They're shook at first. Looks like an image, a ghost, what have you. He says, come on, fear not. Handle me and see. A spirit hath not flesh and bones as you see me have. He's tangible. He's not an image. It's not a holographic projection or something. No, he is real. Handle me and see, he says. That's his challenge. And after they share some, and he never appears, by the way, without eating. I like that. He's my kind of guy. And of course, before long, he also is able to leave. He can enter and leave that space. He's tangible. He's not an image. He's tangible. He can enter and leave that space without passing through any of the 6 sides. Why? Because he enjoys more dimensions than we're aware of, more than the 4 that we're aware of. How many does he have? Don't know. There are some Christian mathematicians that suspect he may have at least 11 dimensions in order to do that by the mathematical techniques that we're aware of. There may be others. Now, why is this so important? When we encounter 1 John chapter 3, verse 2, there's a verse that I suspect you can't understand unless you're a physicist. John writes in his first letter, he says, Beloved, now are we the sons of God, and it doth not yet appear what, by the way, that means we're recreated. The Son of God, in the Hebrew, B'nai HaElohim, it's a term that implies direct creation of God. You and I, before we're saved, are a descendant of Adam. Adam was a direct creation of God. All of us were descendants of Adam and subject to the frailties thereof. When you get to the Gospel of John, and in the Old Testament, the Son of God phrase is used just of angels, Adam and the angels, because that's what he directly created. When you get the Gospel of John in chapter 1, verse 11 says that he came into his own, speaking of the Messiah, he came into his own received him not. But as many as received him, to them gave he the power to become the sons of God. You see the term, he picks up that Hebrew concept of a direct creation of God. He's echoing it here again. Beloved, now are we the sons of God, it doth not yet appear what we shall be. But we know that when he shall appear, we shall be like him. Why? For we shall see him as he is. What's that saying to me? We're not going to see a representation of him. If I show you a photograph of me, you see a 2-dimensional representation of a 3-dimensional person. We know that when he shall appear, we shall be like him. Whatever dimensionality he's enjoying, we will also enjoy because we shall see him as he is, not a representation. And so I think that's, I believe this is an expression of hyperdimensionality. And I don't think you can fully appreciate this verse without the background we've given here. Well, we've talked about the angelic realm, beyond our physical boundaries. We talked about the macrocosm, which is beyond the reach of gravity. We've talked about the microcosm. We ran against what I call the Planck wall of non-locality. We explored briefly the metacosm, the realm of the paranormal, the realm that apparently we find UFOs and demons and all kinds of things, and of course, dominated by angels. And so we're going to explore the reality and limitations of angels, and how can we know for certain about these things, and how does it affect us? This all isn't just an intellectual exercise. It has a hazard, a vulnerability, an impact for every one of us. And so we have gone through this first session, and now we're going to go in the second session about biblical angels, characteristics, limitations, and the lineup of the major players. And so that's in the next session. And all of this is a prelude to another pair of sessions that will explore the invisible war that all of us are already a part of. And we need to understand that. And so with that, praise God. Let's close for a closing word of prayer. Father, we thank you for your word, for we know it's the only reliable counsel. We thank you, Father, for the insights you've given us about the frailty of the reality that we call our physical reality, and yet how much of what you do and what manifests you is far beyond all of that. We do pray, Father, that through your word and through your spirit you would illuminate these things, and above all, that you would illuminate to us what you would have of us in response, that we might be more effective stewards of these gifts that you've given us, as we again commit ourselves without any reservation whatsoever into your hands. Indeed, in the name of and to the glory of Yeshua, our coming King indeed. Amen.